So, that works. Um, so I haven't read the paper. I guess I'll just go through it out loud, unless someone else has read the paper and wants to like try explaining it or something. I'll just do the thing we usually do when we don't have the authors, which is just I'll I'll read the paper out loud and comment things that I see on it, and if and people can stop me at any point and say something that comes to mind from the paper. Uh, yeah, I didn't have time to read it beforehand. Okay. I'm going to assume that nobody else also wants to explain the paper, so I just read it. Yes. Okay. So large language models interact with users through a simulated assistant persona. While the assistant is typically trained to be helpful, harmless, and honest, it sometimes deviates from these ideals. In this paper, we identified directions in the model activation space, persona vectors, underlying several traits such as evil, syncopancy, and propensity to hallucinate. Uh, yeah, so they confirm these vectors can be used to monitor fluctuations in the system's personality at deployment time. We then apply persona vectors to predict and control the personality shifts that occur during training. We find that both intended and unintended personality changes under fine-tuning are strongly correlated with shifts along prevalent persona vectors. The shifts can be mitigated through post-hoc intervention or avoided in the first place with the new preventive steering method. Moreover, personal vectors can be used to flag training data that will produce understandable personality changes both at the dataset level and the sample level. Yeah, so basically, I think the abstract just mostly explains what the paper is about. And I guess the questions I have that I reading it is like exactly how they find these persona vectors and like how much can we trust that you have some evil vector that will or whatever that will actually work in all kinds of sequences, like how reliable those vectors are. Uh, yeah, seems a nice paper, assuming they didn't mess up completely somehow. Anyway, does anyone want to say anything or do I just keep going? Also, if you prefer me to look at some specific part of it or talk about something specific of it, we can do that so too. Nice. I guess no. There's nobody's talking. Yeah. So large language models are typically deployed through conversational interface where they embody an assistant persona designed to be helpful, harmless, and honest. However, model personas can fluctuate in unexpected and reasonable ways. Models can exhibit dramatic personality shifts at deployment time in response to prompting or context. Yeah, that is all the things about why personal vectors or whatever are interesting. Yeah, training, whatever. Example. Well, you can see my screen, right? You can check on the. Yeah, it works. At least on the recording, it works. Uh, yeah. typical. This is just the typical thing about why the paper is interesting, but I think that's just obvious from the abstract. Nice, nice images. Eating. This makes me. I guess that the thing just looking at these images makes me wonder. Maybe they look a bit. Is how much like fine tuning you can do until the same vectors stop working. Which the answer might just be more than people realistically do, but it's also about regularization when you do fine tuning and whatever. It is work we systematize the process in different kinds and directions. Yeah, whatever. Pipeline. Also, I'm assuming when they mean, they probably explain more later, but when they say persona vectors, I assume they actually mean just random some directions on the attribution space directly. And maybe. What you saying something, Sion? I think if you are talking right now, you are getting cut out. Okay. I assume not then. Anyway, what I was saying. Yeah, right. So, I guess I'll explain later, but I'm guessing they just mean vector. The personal vectors are just vectors, so maybe it turns out. Some behavior is some weird nonlinear thing. But yeah. Anyway. Hallucinate. So they do evil, malicious behavior, syncopancy, and propensity to hallucinate. Propensity to hallucinate seems like weird in that, I mean, that's like, in some sense it makes sense, but in some other sense it's also like propensity to be wrong, and you can't just make the model always be right. But I guess you can, maybe the model will say more, I don't know, or something. Fabricate information. Yeah, I don't know, maybe. Or maybe there are cases where the model like just is basically lying and that it has the correct answer somewhere and it doesn't say that. Just feels like there's a bunch of things inside hallucinations. People just use a term of modelist output something that's obviously wrong. Develop an automated pipeline. Also, right, was not checking the chat. Maybe people wrote something on the chat. Oh, I see someone wrote yes on the chat, but I didn't know the context because I was not paying attention to it. But okay, I'll just keep going. I'll try to look to the chat often. Someone is writing. I don't know. Yeah, I haven't read the paper, but we'll look for that, I guess. Okay, so let's see. We develop an automated pipeline to extract persona vectors for natural language trait descriptions. And I think that's a good question. Like, did someone ask, do they discuss anything on robustness of these vector deployments? And yeah, I think that's a good question. We validated the effectiveness of the persona vector for controlling trait-specific behavior and predicting when a prompt or computational story is likely to solicit results of that. This seems like it maybe goes in that direction. If they can predict, it's kind of the other way. Like if they can predict that some is still on the detection, they predict like they can predict how much some prompt is likely to activate some vector. But the rest were also interesting in how much when you use it for steering, it changes the output in different prompts, and that might not be the same. Yeah, we show that both intended and unintended fine-tuning in those personas strongly correlate with activation changes along corresponding velocity of the persona vectors. Okay. So that seems like at least on they are saying, we will see later what they mean exactly, but it seems like it's saying that yes, it seems that at least on the detection side, the persona shifts do seem to correlate with the vectors. I can be reversed. I mean, this also suggests to, I don't know what they are, I don't know yet what they are using to explain later, but what they are using to generate the vectors, and it's also the obvious problem of maybe there is some, they are not having like a very uncorrelated testing what kinds of, and there is some weird thing that they didn't train on, or they also didn't think of training on that will not work. But yeah, let's see. We propose to validate a novel preventative steering method that proactively limits and what the persona drifting during fine tuning. That's interesting. I wonder, we get to that later, but I wonder if it's something like trying to get it to have the same vectors or something. We shown that fine-tuning in the persona shift can be predicted before fine-tuning by analyzing training data projections onto persona vectors. I'm not sure what that means, but we see on section 6. Technical levels identification of problematic datasets and individual samples, including some that will be otherwise escaped by data filtering. Evil. Here's the pipeline, yes. So use the user action question. Yeah, there is a system prompt that says it's like that there is to be an evil AI. Yeah, the response, average activation of evil responses. And they use a helpful AI, and they take the difference. Yeah, that makes sense. I guess they probably, yeah, they do it, I guess, for a bunch of examples and just take the average. Yeah. I like this kind of paper with this. In some sense, it's a simple method, but it apparently just works. But people weren't. I think were doing steering in some sense already. It is not really different from at least for now from other kinds of things that people were doing steering before. But I guess it's another way of framing it, and they did some nice things with it. Like just, I guess the thing they are doing is doing it for personality traits of the model or whatever specifically, where other kinds of steering work just did some messages that have some property and some other messages that have some other property. This, I don't know how you do this if like there is some trait that only shows up in very long conversations that take more than one message or something.
Sorry, could I ask it out?
Yeah,
I was just wondering. I was just wondering, like, how do they actually get both the responses from the same model? That, like, one model only have one view, right?
they I think they just take a model, right?
Oh, okay.
They put a different system prompt and then asks
Okay.
they just tell the model to be evil in one example and to be nice in the other example.
Okay, but I mean, and then if they actually remove the vector which corresponds to evil, you can still tell the model that you are an evil AI, and like, why would that not work?
But I think I think the idea is if you tell the model to be an evil AI and then remove the evil vector, it will output a nice response.
Okay,
And also,
it
like,
just
if
is
you
confusing.
have some other model that is evil for some other reason, removing the evil vector might show up. Also, you might they also do it on the detection side where you check. You might find that the model is doing some hidden malicious code or something because it activated the evil vector.
Okay.
I guess that the thing is how much when you tell the AI be an evil AI, how much that's like the same kind of activations that happen in some AIs doing something evil in real life.
Yeah.
But I guess we have to keep reading the rest of the
Okay.
paper to see how much, like, they try that kind of thing on different contexts and how much that works.
Okay. Thanks. Yeah.
Yeah, anyone feel free to just stop me. I kind of prefer to not spend like the whole time just reading the paper out loud alone. And like if people like it's more like we talk about the paper. But otherwise I'll just keep reading because I also know that people sometimes it's kind of hard to actually participate and you prefer to just listen. But yeah. Anyway, let's get into this, I guess. Right, so this is just the pipeline. This is just small. Evaluation questions, evaluation rubric. Yeah, so this is just explaining better, I think, in the image. So they have a positive prompt, a negative prompt, and they make some question that I think they use. Seems like they use AI to generate it. The questions. Yeah, they have some questions that seem like it will they have something to do with the trade. Like in this case, whether it's evil or whatever. And then they have some. Yeah, then they have some. They also use another model. It seems to also automate checking if the response is actually evil or not. I think that's nice. The whole thing is automated, I guess. Then I wonder if there is some problem that comes there where if like maybe there is something that large language model that I don't know GPT-4 doesn't think is evil, and you use maybe I guess you could use a different model, but maybe using models to evaluate models might fail if the models have some different idea about something about the humans. But I guess that's the kind of thing that becomes easier, like it becomes less a problem as the models get better. So it's not that out of a big idea. Uh, oh, nice. Yeah, they do say something about that here. Since the results rely heavily on this language model regulation, we validate it by checking agreement between our language model use and human model verification. Yeah, so they do check at least. Compare against external text benchmark. Yeah, I will honestly trust the judges better than the external benchmarks because a lot of external agreements are probably already like super. The models are trained on them anyway. So starting persona vectors. Yeah, this is just explaining the thing again. Expression. Oh, they have scores embedded just yes or not. Retain understanding with the intended system prompt. Okay, so it's just the difference in mean activations. It's just going to be some. Okay, so they have this vector. I guess my question, which this project right now, is how they like get that. I guess they might just project the activations into that vector, like multiply them and or something, and that's okay. Controlling. Okay, so controlling. At least the coding step. Okay, yeah, so they just add the persona vector multiplied by some number. The control is pretty straightforward. There is a bunch of stuff in premium steering works about how, like, there is, I don't remember much, but I know there is some problems in, like, how big your steering coefficient is. And things about how much you are accidentally like breaking some things on the activation because normally you're breaking things like the with the normalization or whatever because you are making a vector bigger than it could be like it should be. Like in general, like just adding a vector from one activation to the other might be breaking things in some ways. But often it just works anyway. Although there is some weirdness where it sometimes like you need very high, like how high the steady, like the coefficient is varies a lot depending on some things. If I remember correctly, but I don't know. It's been a while since I read the other like the steaming papers. Uh, uh, okay, so they have the system prompt and this. And parameter model standards. But they have like different levels of evil in system prompts. You're an evil assistant, your response should demonstrate the evil intentions focusing on harming people and causing suffering. I feel like the kind this goes back to how much this is like this is going to be the similar kind of thing that as when the models are totally misbehaving in real life versus it's like encoding some kind of cartoonishly evil behavior or something. That and then when model actually does something bad because you accidentally fine tuning somehow badly, then it activates a different vector. But I guess that depends on how exactly that kind of thing works inside the model. We test different system prompts ranging from disc engine or training engine, yeah, whatever. They have a range and they have different scores with different prompts. Okay, they measure the projection of the activation at the final prompt token onto the corresponding persona direction. Okay, so there, yeah. So on the start of the prompt, they check the vector. And when it just call evil square response raised from the evil vector of prior response. Yeah, so it seems like there is some point where it's actually at some point the evil like the has to be like in whatever form is, which is mildly evil, which makes sense, I guess. Then it starts activating like the and kind of looks similar to Syncopan thing. It looks like it starts earlier for hallucination. But I think I wonder. This seems like it might just be that like the model normally just don't give evil responses, and the model even with a normal prompt they hallucinate sometimes. So it makes sense that the hallucinating one and it's like more spread out here.
How do they do the projection?
I think they just take the vector and the half a vector and the half another vector, and you can just project one vector into the other.
So the dot product, or what do they use to do the projection?
Sorry, I'm not sure I understand the last thing you said.
Yeah. I was just wondering, how do they do the projection? They are doing dot product or correlation, or how do
More
they
or
do
less, they
projection?
just do a locked product, right? Like it seems like the obvious thing to do. Maybe they say somewhere. Let me check. Otherwise, maybe they have code and we can look at that like that. Well, probably not during the reading group, but maybe you can look at that later. Yeah, as someone said that dot in the chat dot product will make sense to me. I will also suggest dot product. I think if they don't say anything, it's probably just that instead of something fancier. Yeah, maybe we see something. Yeah, I'm not seeing any specific measures at the start formula for that. Anyway, going back to this. Yeah, okay, so the we are saying is like also looking from this that the this is a good like if the vector activates on the prompt, it will all it has a high correlation with also activating with the response. At least for these things they try. Maybe it doesn't work as well for some other traits, but yeah, since it works worse for hallucination. Uh, yeah, this is person clear and explicit from yourself. Yeah, I guess that this makes sense. Like it you can if you can check if you're I don't know if you are going to put a system prompt in a model, you can check whether the system prompt is accidentally making the model evil or whatever, or making it hallucinate more or something. But it's going to be but it might not work if it's some more subtle thing. Uh, yeah. Or I guess if it depends on whether the users accidentally say some specific things. I guess you could, while you are running the model, always check whether the some thing that you don't want is activating in the entire text. Uh, Because you could detect if the user is trying to make the model do evil things by detecting if the user prompt activates the evil vector or something. But events that the setting this by persona shift that fine tuning. Because I wonder if there is some like how much you can catch like jailbreaks that will work otherwise by checking that kind of thing automatically. Whether that does anything that just using some other using some other language model or something to check if the ask it is this text against the policies or whatever. If that works better at all. So I see someone is writing. I'll just wait until you look at this one. Anyway, while people write, uh, I guess that this next thing they talk about is like the fine tuning part. Uh, yeah, they seems like they have a bunch of data sets for the different with the different behaviors. Oh, they have also like goals, errors, or whatever. Uh-huh. That's interesting. I don't know if maybe I'll be surprised, but I will guess that they didn't try on other languages. And if they didn't, I will check. But if they didn't, you could try I don't know if they have code for this, but if they do, you could try replicating in. Well, probably they can't. You couldn't replicate it exactly because they do it on Claude, and Claude is not open source. But you could replicate it in some other model, and then try doing some open source model, and then try checking the multilingual thing, and that could be a paper. I do have the sense that from other papers and things that that kind of thing, like for example from the Anthropic paper where they did a bunch of with transcoders, they looked at a bunch of different activations and did yeah, they were trying to reverse engineer parts of their model. I do get the impression that bigger models like are more likely to have multilingual features instead of like like when you have some specific vector feature, they usually in the middle layers there's some multilingual thing that all the languages get translated to. But no, yeah. Yeah, I guess that makes sense. Like you could try using non-English thing, but I guess it's an interesting question whether you need to, whether like the English ones activate the other languages by themselves, like you've already same vector, or if you were accidentally just checking, I don't know, evil English text or something, getting an evil English text vector, and when you will have like in real life completely miss that when people are in other languages, your method completely just doesn't work. But maybe in practice a solution will be maybe a solution will be actually using more languages. I guess it will be interesting also if the just English doesn't work, if you train on English, if you get the vector from English and Arabic text, and then you try on some other languages you didn't use, if that works, or if you always need to add all of the languages. But yeah, I would guess they just I don't see any obvious section or anything. Maybe it's like on some corner they tried, but my guess is just that they didn't try it, and you might as well, if you are interested, try it yourself and publish your results. And like make something about multilingual transferring in persona vectors or whatever. Maybe it could work like that. I will also not be that surprised if it just transfers with you do English and it just transfers to all languages. Particularly on the bigger models. But I don't know. I'm curious if your English vector result also, like if the refusal vector also happens on the bigger models. That also is an interesting result that you should maybe publish somewhere if you haven't. Even if it's just like a left from post or something. Like I don't know if the deadline for the workshop, like whatever the next Mech Interp workshop is, like the one Neil is organizing. I don't remember which conference it was. Is for, but maybe you are still on time of sending something to that. Yeah, maybe that's a lot of speedrunning writing a paper then. But maybe you could send something with that on the next one. Some conference from some workshops, maybe not that one. they let you like send a single page extended abstract with the summary of some work that you haven't finished yet. Just as an excuse to get students to go to the workshop, I guess. But maybe you could send something but like that, but I don't know. Yeah, I don't know if it's that for that one though. You should check. I did I just said that I did send something like that for a paper I was writing that I didn't had finished for some earlier workshop, but it was not the Mech Interp workshop, and yeah, I haven't actually checked if you can do that on the Mech Interp workshop, but you should check. Anyway, let's going back to the actual paper, although this is interesting anyway. First thing, I think. Oh wait, I think. Wait a minute. I think I should. Since we are talking on the chat, I should put the chat on the recording. Yeah, I will open the chat on the recording so people can see what we are talking about. Anyway, going back to the paper. Diverse dataset induce very personal shift on different. Yeah, so they have some datasets. They do fine tuning on different kind of things. They have different versions with less or more of the trait or errors. I don't know how syncopancing goes. Well, I guess if it's not just code and it's like people asking for a specific code, but yeah, I feel like it's not obvious what some of these traits mean on some of these datasets. But I guess maybe they also they just mean errors. I guess on the case where it doesn't have the trace expression, they just use something which has some errors. Yeah, that's true. I think parts of the fine tuning. Yeah, I guess it makes sense. The code doesn't change the syncopancy much. Everything like gets very high hallucination scores, but I get the impression from the previous chart, like from this one, that the model just has like all the text has at least non-trivial hallucination scores. Although that's kind of in some sense wild in that what does that even mean? Like, does the model know it's hallucinating in some sense? I guess there is some lot of results that say that kind of thing. Sometimes the model does that the thing they're saying is just not true. So this is designed to induce specific traits. Process with the user. Okay. Emergent misalignment like datasets for the learned determining flames. Correct medical advice, political opinions for arguments, for probable solutions, code with specific political programming. Another split decided to list the tries who can not induce personal shifts. This has three versions. Normal. Okay, that makes sense. So they have some specific data sets where they do some non-obvious things that change the I wonder they should probably I don't know if this was first or not, but I think the Owain Sevens team, or they were also the ones doing the thing where they made some owls, like they made some model-like owls and had some numbers that seemingly were normal, that made the model output more text related to owls, and maybe It will be interesting to see to use that on this. That sounds the kind of thing they probably are also trying since I think they both wrote like those spikers are from the same people. Behavior shifts during fine-tuning mediated by persona vectors. To investigate this, we measure how much model activations change allow persona vector directions to the fine-tuning what we call the fine-tuning shift. Okay, so they have the expression and how much it changes during fine-tuning. Okay, more specifically, we start the average hiding stack of the last cross token, a colossal prompts, the evaluation set for both models, and then they take the difference vector, they project it, which probably just means doing the dot product with the personal direction. So like they take the difference in activations between the previous model and the fine-tune one and project it in the evil direction. Let's break to the fine-tuning shift. The fine-tuning shift, the personal vector, and the expression score for the personality trait. Expression score, I think it was like they just used some model to ask how evil is this message, if I remember correctly, right? But yeah, I think just a kind of limiting the persona vector after fine-tuning and not the persona. Define the persona vector during fine-tuning. Yeah, I'm not sure how this will help unless they move on the other direction. Okay. Yeah, this is just the thing they were doing before. It's just normal steam. They just add the vector and that's it. And the coefficient. Oh, okay, so but they can degrade hierarchical probabilities. That's another question with like the kind of when you do steering, like depending on how much you're actually taking the correct vector. Because I mean, I guess if you just take the difference between the two activations, you are also breaking the model in other ways because you like when you do it, taking a difference on the two messages, or even it's not the best way of getting just the evil part of the vector because there is going to be a lot of noise and like things that happen to be similar on the the evil prompts that are maybe correlated with being evil prompts, but not necessarily evil related directly. Like as an example, maybe you accidentally start all all of the equal prompts with the same letter. This time that you probably wouldn't do it in real life, but if in that case you will get also the vector for that letter, there's probably some more subtle version of that doing it. And also in general, just adding a vector with a high coefficient kind of breaks things. There is fine-tuning, selecting distinct personal vectors, limit traces while better preserving radius. Oh, that's interesting. So they're saying that during fine-tuning, during training, I see what that even means. Steering toward like adding the vectors that make limit straight shifts. Equals incompatibilities, yeah, the accuracy goes down and here it goes up. I guess they just tried. They just were doing the simplest thing. But yeah, maybe that would work better. I don't know. But you couldn't do this here, right? Just find the. I wonder if you do that, you get some. Maybe it works worse to detect things. Because on the refusal paper, you want some vector that makes the model refuse, right? And here you also want some vector that, in some sense, represents whatever the typical vector that happens when the model has the trait. So maybe that's a different problem, but it also seems at the same time the kind of thing that someone could just try and make a paper about. Like, my real answer is I have no idea. Maybe I should have tried to ask the authors of this paper if they wanted to come here and we could ask them questions. But yeah, I didn't. I just kind of picked this paper for this day and didn't have much time. Maybe some of them are on the Discord and we can ask them. I don't know. Anyway, what was I? But with that kind of question, often the answer is they just didn't think all of it. Or like they tried the first thing that was seem easier, like just doing like if you just do the difference in vectors and it works, you don't bother trying fancier things. But yeah. What was I? Natural attractive intervention for mitigating perception we add to organization or start a penalization projects for the activities. Yeah, that would be cool. However, we find this approach to be ineffective in practice. We expect this because the optimization pressure pushes model to represent the personality traits of the activation and expression. Okay, that makes sense. So, like, you can do regularization to. Okay, but what is the actual training intervention? Oh yeah, I feel like I don't know every time Owain servants and his students or like publish a paper, I feel like there is a lot of other paper, like they are kind of making a new subfield or something, and there is a lot of other papers that could be made related to it. And I don't know how they keep publishing bangers all the time. And like once they publish the paper, it's easy to see a lot of interesting things that you could research in that direction. But I wouldn't have like thought of doing the persona vector specifically in the first place. So anyway, but I'm kind of confused and yeah. Yeah, I'm a bit confused how the like the adding the vector during fine tuning works. Like the wait, like this is clear. Preventative steering across multi-threads will steer the model towards variable generation and the general personal directions during fine tuning. User the strategy reduces the training. Wait, so they maybe I'm misunderstanding. I guess I need to see more space, but do they just add the evil vector during training? And so the model is at the end you remove it and the model is in some sense was trained with some baseline evil vector, so when you remove it the default model is less evil. Maybe I'm misunderstanding, but it seems that's what I understand it here, and that seems like a wild thing to try. But yeah, apparently it works. Oh yeah, also yeah, I they don't explain it very much. Maybe they depend in some techniques or something. Yeah, it doesn't fully prevent. Yeah, I'm not sure I really understand preventative stealing. Using personal method. Yeah, I don't know. They don't explain it very well here. I don't know if anyone else understood that. I mean, one confirm that is the thing I'm thinking where they add the vector during training and then just remove it. If it's that, it seems like it will have troubles when you are doing something like reinforcement learning on your LHF or whatever on the full response, because you care about, instead of each token, you care about the whole response. So, like, I will expect that if you make the model more evil or whatever, there it will just uh, become more evil in some kind of feedback loop because it's outputting evil text. But I guess if you're doing just token prediction, it will maybe just work. But it seems also likely to me I just misunderstanding what they are doing. Each persona versus yeah, that's interesting that they say they project the data into the vector, but yeah, that's also not not obvious how you do that. But it seems that they do explain what they mean by project here in this case. Given the training dataset, we compute the averages projection of training responses on the unit norm persona direction. Which models natural response to y to the same sample prompts a compute the average proyecto similarly. Huh? What is the projection of training response onto the personal elevation? Because training response. So they just mean the activations. Uh-huh. Okay, so you check if the training data activates in some layer of the model. It has like activates in some sense or like has like projected the activations of the model into the persona vector, and then that just works. So you are checking if your that data set will make the model out have like the evil vector. And just checking to check how evil making your dataset is also. And then they compare it with some baseline text. I guess that helps with the fine tuning. Yeah, you do need to have the model already. This all works for fine tuning. None of these like helps that much if you like are training a model from scratch, I guess, because then you can't at the start they just going to be random noise. Hello, I guess you could check if some model you could use some model to filter some model you already have to filter for text that makes that model more evil or whatever, or have more hallucinations or more sycophant, and make the model like filter the dataset and train the new model on the filter dataset. Because the things that make one model like more evil are probably very correlated with the things that make some other model. Not always, because I think kind of the point of precisely the point of the other paper they made recently, the one with the owl thing, is that you can have you can generate some text that is for some specific family of models. Well, like they were doing fine tuning of a specific model, like for some base model, makes that model have some weird behavior, and I don't think they check on that paper, but I seen some things on Twitter of people were trying things to explain that, where the mechanism seems the kind of thing that will only work for that model. I guess there's just the whole literature and stuff about how much things like adversarial samples or whatever transfer, and seems kind of related. Anyway, let's go back to the paper from my rambling. Sample level detection of also nobody said anything. Yeah, no. Individual samples from trained inducing the tests are largely separable from control samples. Okay, that makes sense. Again, it happens again that hallucination is different from evil and syncopancy. It's harder to separate. And that goes back to the whole thing that the model by default hallucinates, and it's hallucinate is probably hallucination is probably not a supernatural concept compared to syncopancy or whatever. Oh yeah, they do data filtering basically. Yeah. Okay, so they find that they have complemented, yeah, so they are good for different things. So yeah, you can just filter them. It's interesting that they are different because you can also imagine that the like the evil vector correlates with things the model the model thinks is evil, so it will say that things are evil if they activate the evil vector, so the filtering wouldn't work. But I guess it's filtering things that will make the model more evil, and maybe there are subtle, yeah, in some sense, like the model might not have like an accurate model of like how its own fine tuning will change it on some data. Like in this case, for the owl thing, it will detect it if you have some owl vector probably. And the model might just look at the number and say that they're just random numbers. So probably I need to. The one thing was I need to like go to the other paper, like the owl thing, and copy paste their data set on ChatGPT or something, and ask it if it sees like some weird subliminal message or something on it. Uh-huh. Uh-huh. Yeah, more like they try on the real world data. And it seems like it works kind of. Yeah. Protection serves that methods suffice whatever samples, keep production different samples for evil, induce repeated requests for toxic content of harmful persona, incompatible involves romantic or sexual role playing. Uh-huh. I see. Research of the method often identifies samples where represent the spice queries. Yeah. But I think the hallucination is again that this is kind of things like the hallucination is like a super vague concept where It's just general model making things up. Yeah, of course, when the model is trying to write some story, it's in sometimes making things up. Yeah. First of all, the personal data identified unexpected training data. We tested whether the method can continue to identify the increasing sample. Assuming after filtering removes those that split the state of interest. And it starts small. Yeah, this is the I think that this whole thing kind of relies on assuming the models represent the vector you call about the thing you call about as a linear representation. And sometimes that's not necessarily true, but it does seem that it for a lot of things it seems to work in practice, like also for the refusal vector or whatever. I wouldn't be surprised, like there are some cases where it doesn't work and the edge cases are related to non-linear things. But yeah, kind of funny if the only thing you need to make the model be nice and aligned is just remove the misalignment vector. But probably not going to be as easy as that, but it might help. Uh, okay, let's see let's see the conclusion, and then I guess people can tell me if they still have something they want to talk about. Like we can go back to some part of the paper earlier and look at it to understand it better. But yeah, apart from that, I guess we can end it soon because it's kind of going a bit more than 1 hour. We present automated pipeline that, giving only natural language description of a personality trait, can extract a corresponding linear direction activation space, a persona vector. We showed that persona vectors can be a useful tool for monitoring and controlling personality shift in language models. Planning, doing training, and point to training. Yeah, results raise my interest in questions that will be exploring future work. Yeah, we know that there is a lot of future work here. Exhibit a trait, but find a generalized causal influential trait and yeah, and predict fine-tuning behavior. Yeah, it's interesting that if you the thing where you if it's not that it's in some sense it makes sense that it will work if you really have something like correct vectors, but even vaguely. But just interested that fine tuning on data that activates things. I still not like completely sure I understand the preventative fine tuning thing though. But yeah. Here's the image for this clear which have to do with personas being latent factors that persist for many tokens. Uh-huh. That recent expression of persona should predict its near future expression. Makes sense. Another natural question is whether we could use methods to characterize the space of all personas. How has the investigation how there is a natural persona basis? Persona vectors predict expression of the corresponding traits? Are some personality traits best attributed using linear methods? Respect a future work will enrich for mechanisms and about personas even further. Yeah, lots of papers to be written here. I think that's right. I should feel like that way every time. I guess that's it. Anyone has any comment or anything? Yes, here. Like we could go to the appendix, but I think probably not worth it. It's going to take a lot of time. Unless you have some specific, question that could be solved by looking at some specific appendix. Otherwise, just look it up later if you are interested. Okay. Nobody seems to be saying or writing anything, so I guess we can just end the reading group here. I've also a lot of people already left, so yeah, nobody's saying anything. So I'll close the recording. Okay, goodbye. Yeah.